proofs are proofs where, what, you guys know what indirect means?
Not direct.
Like out of the way kind of thing.
Yeah, kind of like a roundabout way of doing it. So indirect proofs are proofs where you start by assuming the opposite of what you want to prove. So there's kind of 3 steps. Assume, opposite, or the book calls it assume the negation of what you're trying to prove.
I guess.
Okay, and then you find a contradiction with that, with the false assumption, and then let's see how they say the last part. And then you conclude assumption is false, so original, what you're trying to prove is true. I'll just say, so original must be true. Yeah. Anyway, okay, let me give you an example. That might seem kind of vague and unclear. So let's say I was trying to prove it is sunny outside today. Okay, if I was trying to prove it indirectly, I would use this. I would assume the opposite of what I'm trying to prove. So like, what's the opposite of it being sunny outside? So it's raining outside. So that would be my assumption. So let's assume it's raining outside. Now if it was raining outside, I need to find a contradiction. If you guys were coming in from lunch, you guys should probably be wet, like we're last week when it rained. So that's a contradiction with my assumption. Therefore my assumption is false and it must be sunny outside. Okay? So you assume the opposite of what you're trying to prove, then you say, you find a reason why that can't be possible, then you say, therefore my assumption is false, and if the negation is false, then the original statement must be true. If you say the opposite of what you're trying to prove and then show that can't be, then what you're trying to prove must be true. That's what it is. All right. Let's do a couple examples. Let's do one geometry or algebra example, then we'll do one geometry example. So okay, so they're saying if x is 4, then 3x plus 7 is not equal to 22. If I was trying to prove this indirectly, what would I start by doing? You guys remember what I said? Assume the opposite of what we're trying to prove. So what's the opposite of what we're trying to prove? Yeah, assume 3x plus 7 is equal to 22. Okay, well, what's wrong with 3x plus 7 being equal to 22? Well, if you plug in, we know that x is 4, this is like our given. If we put in 4 for x, it's not equal to 22. Therefore, that's a contradiction to our assumption, and the original statement must be true. What is 3? 3 times 4 plus 7 equals 19. Which contradicts our assumption, therefore the original statement 3x plus 7 is not equal to 22 must be true. Okay, this one's a little more, applies to today a little bit more. So on this problem, triangle ABC is supposed to be scalene. This is the given. What did scalene mean? All the sides in the big triangle are not equal. Then what we're supposed to prove is that BD is not a perpendicular bisector. We kind of use this logic sometimes without even thinking about it. Like, I don't know, something really simple. Like if somebody normally does well and then on the test they didn't do well, you might think like, oh, they didn't study or they're tired or something's wrong. Anyway, so if BD, how do we start this if we're going to do a indirect proof? What did I say we start with? Assume what? Opposite what you're trying to prove. So what are we going to assume? Okay. Assume BD, segment BD is a perpendicular bisector. By the way, these proofs are like paragraph form, not like statement reason as much. Assume it is a perpendicular bisector. Now, if that was true, then what would I know? If BD is a perpendicular bisector, what would I know? Okay. BDA is 90, BDC is 90. By definition, a perpendicular bisector. What else would I know? Bisector means what? Means it cuts this in half. So AD would be congruent to DC. What else do I know about these? BD is congruent to BD. So what do I know about these two triangles? Triangle ADB is congruent to triangle CDB by side angle side. And if those two triangles are congruent, why do I know that AB and BC are congruent? Yes, because they're corresponding parts of congruent triangles. And why is that a problem? Because ABC is supposed to be scalene. Is this scalene? No. That's two equal sides in the big triangle. So, if that's a contradiction to what I know must be true, therefore my assumption is false, that it's perpendicular. Therefore, it must not be a perpendicular bisector. Some things just kind of lend themselves. I hope you guys got that one because there is one like that on the homework today. All right, you guys ready? Now, if I was doing the actual thing, I should have written everything we said down. So it'd be like a big old paragraph. But I'll wait until we get to that part before I start writing. Number 1 says write the negation of each statement. What is the negation of today is not Friday? Today is Friday. Number 3, the integer y is even. What's the negation?
Y is odd.
The integer y is odd. I want to go back and talk about 2 and 4 because you guys probably or might have forgot that. What's the negation of all dogs bark? Okay, no, not no. If it's not all, that's like saying some don't. So it's some dogs don't bark. some not dogs bark. Alright, on 4, what is the opposite of greater than? If I said Jim his age is greater than yours, but then you turned out I was lying, what must the truth be? What's not greater than?
Oh, wait, is it like along the line of age?
Less than or equal. If their age is not older than yours, they could still be equal to yours. So the opposite of greater than is less than or equal to. Okay, number 5, write the contrapositive. You guys remember contrapositives? Okay, it's negation. Well, it's the big word, so you do the converse, switch the order, and the inverse, negate both. So it's the big one. So if the car is out of gas, it will not start. If the car doesn't start, it's out of gas. So you negate both and switch the order. Oh wait, no, that's not right. It said the car didn't start. If the car does start, so yeah, we didn't negate it. If the car does start, then it is not out of gas.
You always see that. You did.
Or it does have gas, yeah.
He hasn't talked to you. You say every.
Okay, number 7, if angle 1 is congruent to angle 3, then triangle ABC is congruent to the triangle DEF. So if triangle ABC, what? Is not congruent. So you can just put the congruent symbol with the not symbol. Is not congruent to triangle DEF. Then what? Yeah, angle 1 is not congruent to angle 3. Do you guys know how the original statement and the contrapositive are related to each other? They are basically saying the same thing. They're the same statement said backwards. If you think about number 5, the original and the contrapositive, what we wrote, are saying the same thing. If the car is out of gas, it won't start. If the car does start, that means it has gas. Alright, anyways. Number 9, write the initial assumption for the indirect proof of each statement. What's the initial assumption supposed to be? If we're the opposite. So basically we're supposed to negate what we're trying to prove here. If a car has anti-lock brakes, that's like the given part basically, it will not make skid marks on the pavement. So if we're trying to prove that was wrong indirectly, what would we start by assuming?
The car has anti-lock brakes. It will make skid marks.
You don't have to rewrite the car has anti-lock brakes. Assume the car made skid marks. You're still using your hand. Number 11. If y equals 27, 3y equals 81. So what are we going to start by assuming?
No.
Assume what? So the given is y equals 27. What they're claiming is 3y equals 81. So 3y is not equal to 81. Okay, so part of writing a indirect proof is finding the contradiction. So on 13 through 16, we're practicing finding a contradiction. So which two statements are contradictions? Which of these cannot exist simultaneously? So line P says lines J and K intersect. Line Q says lines J and K are coplanar. Is it possible for two lines to intersect and be coplanar? Yes, that would be like these two lines. They're coplanar because they're both on the whiteboard. They intersect. Okay, so it's not P and Q. Line R says lines J and K are parallel. So which options could not coexist? P and R. It can't be intersecting and parallel at the same time. It's contradictory. So it's P and R. Okay, 15. Angle C is acute. Angle C is not equal to 90. Angle C is obtuse. Which of those cannot coexist? P and R cannot be an acute and obtuse angle. Their definitions do not jive with each other. Okay, on 17 it says, state whether each pair of statements is contradictory or not contradictory. If they're not contradictions, explain why not. So if they do not contradict each other, we got to give a reason why they work together. Okay, number 17, is this a contradiction? God's word is truth, God's word is fallible. Is that a contradiction?
Yes.
Yeah, so on 17, we're just going to put contradiction. Okay, 19 is kind of a trick question. It says, if triangle XYZ is equilateral, can triangle XYZ be isosceles? Can it be equilateral and isosceles at the same time?
Yeah.
Okay, here's the trick. What's isosceles mean? Two equal sides. Okay, but we never said only two equal sides. So in other words, two equal sides doesn't mean it can't have three equal sides. So that's kind of a trick question. But anyway, it's not a contradiction. Because a triangle with two equal sides kind of makes sense. For 18 and 20, there's one of each also, just like the odds. So there's one contradiction, one not contradiction. All right, 21. Write the modus ponens or modus tollens argument illustrated by each Venn diagram. That sounds confusing, but once we do it, it'll make more sense. Modus ponens, you probably forgot, but it means like, if I win the lottery, I'll buy a new car. Yesterday I won the lottery, what can you assume? I bought a car. Or modus tollens was like the contrapositive version. Like, I didn't buy a new car, so I must not have won the lottery. That's, anyway, don't worry about that too much. You guys will get this in a second. So on the 21, the first one, it has the dog circle in the Venn diagram inside the mammal circle. What does that mean? If an animal is a dog, then it is a mammal. Okay, now we're supposed to say something about Sparky. Do you guys see Sparky in the picture? What can we say about Sparky? Sparky is not a mammal because he's not in the mammal circle. Therefore, what else do we know about Sparky?
He is not the dog.
He is, or it is, I don't know if it's a he or she, but it is not a dog. That would be the contrapositive logic, modus tollens.
Sparky sounds like a dog name, though.
It's
It is.
It could be a Sparky or male.
They're subverting expectations. All right.
I hate this.
23, we're talking about integers and rational numbers. You guys remember what integers are?
-3.
-3 is one of them. They're like all the numbers on a number line. No fractions, no decimals. Negatives, positives, 0. Okay, what are rational numbers? Rational numbers are almost everything, anything that can be written as a fraction, a over b. But what do you think those two circles are implying about integers and rational numbers? What are those two circles saying about integers and rational numbers? If a number is a what? Is an integer. Then it must be, and it is a rational. Because -3 is an integer, it's also rational because you can write it as -3 over 1. So what are we supposed to say about -3? -3 is what? Is an integer. Therefore, -3 is a rational number. Yeah. looking for.
That's purposeful.
You got this one, though.
Okay, on 31, it says the given is that angle 1 is not equal to angle 3. And we're supposed to prove that lines M and N are not parallel. If I'm trying to prove lines M and N are not parallel, what am I going to start by saying? Assume what?
They are
Assume they are parallel. Assume lines M and N are parallel. Well, if M and N are parallel, what do we know about angles 1 and 3? Why would angle 1 and angle 3 be congruent?
Because they're alternate exterior angles. Wait.
Because they're alternate exterior angles. I'm just gonna say by the alternate exterior angle theorem. Oh, yeah, I'll probably put something along these lines on the fence.
Oh my gosh. M and N are M&Ms.
Okay, well, we're already at the contradiction, right? Because we just said angle 1 and 3 are congruent. And that contradicts the given that the two angles have equal measurements. This contradicts the given. Therefore, the assumption is false. And the lines are not parallel.
Let's go. That was top 10 epic gamer moves of all time.
Okay, on 32, I'm not going to do this one, but it's starting with the given that BD is an altitude and triangle ABC is scalene. So you're supposed to prove that BD is not also a median of the triangle. So you assume it is a median, and then you argue until you show that, kind of like my example at the beginning, you give an argument until you get to show that the triangle is not scalene. And then that's your contradiction. You say therefore BD can't be median. So I'm going to be looking for the assume, a couple lines in the middle about like the triangles being congruent and why that would make triangle ABC not scalene. Anyway, I'll let you guys give it a shot.